Section R.1, Factor, Prime Factorization, Least Common Multiple, Least Common Denominator. Writing a number as a product of prime numbers. By definition, a factor is any number that divides another number evenly with a remainder of 0. By definition, a prime number is a natural number greater than 1 whose only factors are 1 in itself, basically divisible by 1 in itself. Composite number, a natural number greater than 1 that is not prime, meaning it's divisible by 1 and other numbers. Prime factorization, writing a composite as the product of its prime numbers. For example, write the prime factorization of the number 36. There are various ways of writing 36 as the product of two numbers. Suppose 36 equals 9 times 4. However, 9 nor is 4 prime. They are composite, so they can be written as the product of two other numbers as well. Well, 9 is 3 times 3, and 4 is 2 times 2. So therefore, 36 broken all the way down into its primes is 3 times 3 times 2 times 2. Or we say for short, 2 to the second power times 3 to the second power for shorthand. Note, except for the number 2, the only prime even number, if a number is even, then it will not be prime, therefore it can be factored. Write the prime factorization of 108. Well, since 108 is even, we'll start dividing it by 2. 2 goes into 108 54 times. 54 is an even number, so we'll divide it by 2 as well. 2 goes into 54 27 times. 27 is an odd number, therefore we'll try dividing it by 3. And 3 goes into 27 9 times, and we know that 9 is actually just 3 times 3. So therefore, the prime factorization of 108 is 2 times 2 times 3 times 3 times 3. Or, for shorthand, 2 to the second power times 3 to the third power. Write the prime factorization of 192. 192 is an even number, so we'll divide it by 2 first. 2 goes into 192, 96 times. 96 is also even, so we'll divide it by 2. 2 goes into 96 48 times. 48 is an even number, so we'll divide it by 2. 2 goes into 48 24 times. 24 is even, so we'll divide it by 2. 2 goes into 24 12 times. 12 is even, so we'll divide it by 2. 2 goes into 12 6 times. 6 is even, so we'll divide it by 2. And 2 goes into 6 3 times. So the prime factorization of 192 is 2 times 2 times 2 times 2 times 2 times 2 times 3. Therefore, shorthand, that is 2 to the 6th power times 3. Finding the least common denominator LCD or least common multiple LCM. By definition, least common denominator is a list of the smallest positive numbers divisible by all the denominators in the list. One of the surest and safest ways to find the LCM or two different numbers, or for two different numbers, is to break them down into their prime factors. If possible, once that is done, you pair up what they have in common. A pair counts as one whole, and what's remaining is put back into the product of those numbers. Note, the least common denominator is also the least common multiple of the denominators. See the examples on the next slide. Find the least common multiple of 2 and 10. Well, what we'll do is we'll list some multiples of 2, 2, 4, 6, 8, 10, and so on. And then we'll list some multiples of 10, which is 10, 20, 30, and so on. So what we're looking for here is the smallest multiple that they have in common. And as you can see here, the smaller multiple they have in common is 10. Therefore, the least common multiple for 2 and 10 is 10. What about 3 separate numbers, 9, 6, and 18? So once again, we'll list some multiples of 9. We'll list some multiples of 6. And we'll list some multiples of 18. As you can see, they all three have a multiple of 18, which is the smallest. Therefore, the least common multiple for 9, 6, and 18 is 18. Find the LCD of 1 over 8 and 3 over 16. So we'll take the two denominators, 8, and list some multiples of 8. We'll list some multiples of 16. And we'll go back and see which one of them they have the smallest that's in common, which in this case is 16. Therefore, the least common denominator is 16. Likewise, 1 over 20, 2 over 15, and 7 over 30. We'll list some multiples of 20. We'll list some multiples of 15. We'll list some multiples of 30. We'll go back and take a look. The smallest multiple that all three have in common is 60, as you can see. Therefore, the least common denominator for these three denominators is 60. Section R.2, fractions. Determine whether two fractions are equivalent is nothing more than reducing the fraction into a smaller fraction to see if they are equal. Also, if their cross products are equal, then the two fractions are also equal. See below. For example, determine if 3 over 5 and 15 over 25 are equivalent. Well, 3 over 5 cannot be reduced any more than itself, so it's 3 over 5. However, 15 over 25 is reducible by 5, which is 3 over 5. So therefore, these two fractions are equivalent. Now, the cross product method is very simple. First step is you set the two fractions equal to one another, and then you cross multiply. So you do 3 times 25 on one side and set that equal to 5 times 15 on the other side. You do the multiplication. 3 times 25 is 75, and 5 times 15 is also 75. 75 equals 75. Therefore, the two fractions are equivalent. Writing fractions in simplest forms. Writing fractions in simplest forms is nothing more than reducing the fraction into a smaller and yet still equivalent fraction. This can also be done by using the prime factorization of a number if possible, meaning the person deems that method appropriate. See below. Write 8 over 18 in simplest form. Well, both 8 and 18 are even numbers, so therefore they are reducible by at least the number 2. So therefore we'll divide them by 2 first, which will get a result of 4 over 9. 4 over 9 does not reduce any smaller than what it is, so therefore it will remain 4 over 9. 39x over 51, we want to write that in simplest form. Now, just because a variable has been thrown into the fraction doesn't mean we still cannot apply the rules of reducing. Can 39 and 59 be reduced? Yes, it can. Both of them can be reduced by 3. 3 goes into 39 13 times and goes into 51 17 times. However, we will keep the x because the numerator started with the x. We cannot simplify it, so therefore it follows the final answer. What if the fraction becomes negative? Same process. We can still reduce it. Both 12 and 27 are reducible by 3. And if we did so, 3 goes into 12 4 times, and 3 goes into 27 9 times. So therefore we get an answer of negative 4 over 9. Why is it negative 4 over 9? Because the fraction started off negative. Therefore the result is also negative. Multiplying fractions. When multiplying fractions, we do not concern ourselves with making sure that the fractions have the same denominators. For that reason, we can simplify, find the product of the numerators, and putting that over the product of the denominators. Remember, simplify whenever possible. If A, B, C, and D represents numbers negative or positive, and B and D are not equal to 0, then A over B times C over D equals A times C over B times D. First example, multiply 3 over 7 times 5 over 11. Well, 3 times 5 is 15, and 7 times 11 is 77. These do not reduce, so therefore we leave it as a fraction. Two over 3 times 6 over 8 becomes 12 over 24. However, both 12 and 24 are reducible by 2, but in this instant, we want to try to use the biggest number we can think of that would divide into both 12 and 24, and that number happens to also be 12. So if I divide 12 into 12, it goes 1, and if I divide 12 into 24, it goes 2. So therefore, the answer reduced to lowest terms is 1 over 2. Dividing fractions. When dividing fractions, we do not concern ourselves with making sure that the fractions have the same denominators. When dividing fractions, we multiply the first fraction by the reciprocal of the second fraction, a process often known as copy, change, flip. Once this has been done, you apply the process of multiplying fractions, which you already know. Remember, simplify whenever possible. For example, divide 8 over 7 by 2 over 9. So first step in the process, copy, change, flip. So what we've done here was we've copied the first fraction down again, which was 8 over 7. We've changed the sign from division to multiplication, and we flipped the second fraction from 2 over 9 to 9 over 2. And therefore we are going to multiply straight across. 8 times 9 is 72, and 7 times 2 is 14. But both of these are reducible by 2. And therefore, if I reduce them by 2, I get an answer of 36 over 7. And no, this does not reduce, so we will leave it as a fraction. There is technically no need to turn this into a mixed number unless otherwise told to do so. Here we have two fractions that are also being divided. So again, we'll apply the copy, change, flip method here. So we will copy the first fraction down, which is 5 over 4. We will change the sign from division to multiplication, and we will flip the second fraction, which becomes 2 over 3. We will therefore cross multiply straight across. So we will have 5 times 2, which is 10, and 4 times 3, which is 12. And both of them are reducible by 2. So if we did such, we will get a result of 5 over 6. Adding and subtracting like fractions. When adding fractions, you must have a common denominator to add them immediately. Always, always, always check to see if fractions have the same denominator when adding and subtracting them. If the denominators are alike, then you can proceed by combining the numerators by the operator sign in the middle of the fractions. Remember, simplify a fraction whenever possible. See the examples on the next slide. Add 6 over 13 to 2 over 13. Same denominators, we're going to combine their numerators with the sign in the middle. So 6 combined with 2, 6 added to 2, or should I say a positive 6 and a positive 2, same signs. I'm going to add and keep the common sign, which will give me 8 over 13. Add 5 over 7x to 2 over 7x, same denominator, combine their numerators. Therefore, we will get 5 combined with 2, or 5 added to 2, or positive 5 combined with the positive 2, same signs, add and keep the common sign, gives me 7 over 7x. However, 7 over 7 actually reduces by 7. 7 goes into itself one time and goes to itself one time in the denominator, with the x remaining in the denominator. So the answer is basically 1 over 1x or 1 over x. However you want to write it, it's the same difference, but it is 1 at the top and the x is at the bottom. Subtract 11 over 18 from 5 over 18. Once again, same denominators, combine the numerators with the sign in the middle. So we have a positive 11 being combined with the negative 5, which are pronounced as unlike signs, and therefore, unlike signs, you subtract and keep the sign of the larger number. So therefore, you take 5 from 11, which is 6, and it's a positive 6 because 11 was the larger number. However, 6 and 18 are reducible by 6, and if you did such, 6 goes into itself one time and goes into 18 3 times, so the answer in reduced form is 1 over 3. 10 over 2x is being subtracted by 4 over 2x. Once again, same denominators, combine them with the sign in the middle. Therefore, we have 10 being combined with the negative 4, which are unlike signs, so we are going to subtract and keep the sign of the larger number. Therefore, we take 4 from 10, which is 6, and it's a positive 6 because 10 was the larger number. However, 6 and 2 are both reducible by 2, and if we reduce them by 2, we will get a result of 3 over x or 3 over 1x. However you want to say it, it's the same meaning. As long as there's a 3 in the numerator and an x in the denominator, that's the final answer pretty much. Adding and subtracting unlike fractions. When adding and subtracting fractions, the fractions must have a least common denominator, LCD. If the fractions do not have the same denominator, you must make it so that they do have the same denominator. See the example on the next slide. Here we're being asked to add 2 over 7 to 8 over 21. They have different denominators here. The least common denominator for 7 and 21 is 21. So what we will do is take this back into the old-fashioned methods. So we'll take the original fraction, set it equal to something over 21, which is the LCD, and we'll take the second original fraction and again set it equal to something over 21, making sure that all signs carry with the new fraction. So therefore we take 7 into 21, which is 3. 3 times 2 is 6. 21 goes into 21 1. 1 times 8 is 8. So our new equivalent fractions are 6 over 21 now being added to 8 over 21. Same denominators, combine their numerators. So 6 and 8 gives us 14 over 21. And 14 and 21 are reducible by 7. And if you reduce them by 7, you get a result of 2 over 3. Subtract 5 over 6 from 1/2. Once again, we need to find a common denominator for 6 and 2, and that is going to be the number 6. So once again, as in the previous example, we are going to set the old fraction equal to something over 6 and the old fraction at the bottom set to something equal over 6, remembering to carry over the signs that the fraction started with. So let's do 6 into 6 goes 1. 1 times 5 is 5. 2 into 6 is 3. 3 times 1 is 3. Our new equivalent fractions are 5 over 6 and a negative 3 over 6. Unlike signs, subtract 3 from 5, which is 2. So we get 2 over 6. However, 2 over 6 reduces down by 2 to be 1 over 3. Adding and subtracting mixed numbers. When adding and subtracting mixed numbers, change the mixed numbers into improper fractions and apply the process you've learned from previous sections. Remember, when adding and subtracting fractions, you must have a least common denominator. Add 2 and 1 over 6 to 4 and 2/5. So we'll turn the mixed numbers into improper fractions. So we'll take 6 times 2 plus 1, and we'll take 5 times 4 plus 2. So our new improper fractions are 13 over 6 and 22 over 5. The least common denominator for 6 and 5 is going to be 30. So we will set the old fractions equal to something over 30. 6 goes into 35 times. 5 times 13 is 65. 5 goes into 36 times. 6 times 22 is 132. Same denominators. We can now combine the numerators. Therefore, we get 197 over 30 as the improper fraction, and if need be, turn the number into a mixed number if necessary. What the heck is going on here with this app? 9 and 7 over 15 is being subtracted from 4 and 2/5. So again, we will turn these mixed numbers into improper fractions. 5 times 9 plus 7, and 4 times 5 plus 2. So we get 142 over 15 minus 22 over 5. Once again, the least common denominator for 15 and 5 is 15. We will set the old fractions equal to something over 15. And we will take 5 into 15, which goes 1 times 142 is 142. Five into 15 goes 3. 3 times 22 is 66. Same denominators. We can now combine the numerators. If we did so, we get 76 over 15. Multiplying and dividing with mixed numbers and whole numbers. When multiplying and dividing mixed numbers, change the mixed number into an improper fraction and apply the processes you've learned from previous sections. Multiply 1 and 2/3 times 7 over 8. We will turn the mixed number into an improper fraction by doing 3 times 1 plus 2. So we get 5 over 3 times 7 over 8, which is 35 over 24, and it does not reduce, so we will leave it as a fraction. divide 3 and 2 over 7 by 2 and 3 over 14. We will turn the mixed numbers into improper fractions. So we'll say 7 times 3 plus 2 and 14 times 2 plus 3 and get the new improper fractions of 23 over 7 divided by 31 over 14. We are dividing two fractions, so we will apply the copy, change, flip method. So therefore we will copy the first fraction down again. We will change the sign from division to multiplication. And we will flip over the second fraction. And we will multiply straight across. And this reduces by 7 to be 46 over 31. Section R.3, decimals and percents. Decimal notation in writing decimals in words. Decimal numbers by definition is a number written in decimal notation. Here we have a place value chart. Starting with the decimal point, the numbers to the right of the decimal are pronounced with the THS at the end. So that's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. The numbers to the left of the decimal go up as ones, tens, hundreds, thousand, 10,000, 100,000, millions. It is very important that you know your place value. Very, very, very important, especially when it comes to rounding decimals. Writing and reading a decimal in words. Writing and reading a decimal in words is literally writing the decimal numbers into words. See the following steps below. See examples on the next slide as well. Step 1, write the whole number in parts. Step 2, write and for the decimal point. Write the decimal point, which is step 3, in words as though it were a whole number followed by the place value of the last digit. 0.06, pronounced as 0 and 600ths. Although the 0 to the left of the decimal isn't absolutely necessary, you can simply write it as 600ths. B, negative 273 thousandths, as that's pronounced. Therefore, writing in words is spelling it as negative 273 thousandths. C, 0.0829, pronounced as 829 10,000ths. So in words, that's 829 10,000ths. $596 has to be written in standard form. So you're taking the words and writing them in numerical form. So therefore, 596 as a decimal is 500.96. $39 and 42 thousandths, written as a decimal, is 39.042. Writing decimals as fractions. So here's a chart where on the left hand side, the first column, you have the decimal number. The middle column, you have the number written in words. And the third column, you have the words written in fractional form. And of course, if you can reduce a fraction, then you should. So you have 0.8 as a decimal. In words is spelled 8/10. As a fraction, it's 8 over 10, which is reducible by 2 to be 4 over 5. And so on and so forth. So take a few minutes, if you will, and pause the presentation, pause the video so you can review and get a good, clear view of what's going on this table. Comparing decimals. The best way to compare decimals is to compare the digits in the corresponding decimal places to see if they are greater than, less than, or equal to. See example on the next slide. Insert a less than, greater than, or equal to form a true statement. Which symbol will make these two statements true? Well, let's start. Both decimals have the same whole number of 26. Don't really tell us much about the number. However, there is a 0 in the tens place in 26.068. There is a 2 in the tens place in 26.28. Since 2 is bigger than 0, therefore 26.28 is greater than 26.068. Therefore, the symbol that belongs in the middle is the less than. Adding and subtracting decimals. When adding and subtracting decimals, you can actually treat them like any other number. However, you do need to be mindful of how the decimals are presented. See the steps below. Step 1, write the decimals so that the decimals line up vertically or on top of each other. Step 2, add or subtract just like you would with normal whole numbers. Example, add 19.52 to 5.371. So 19.52 will be lined up first, and under that we'll have 5.371. 1, 2, and 7 is 9, and 5 plus 3 is 8. Bring your decimal down. 5 and 9 is 14. Carry your 1, and 1 plus 1, of course, is 2. 19, which actually can be written as 19.000, and under that you can have 26.072. Notice we're lining the decimals up so it makes the addition easier. 0 and 2 is 2, 0, 7 is 7, 0 and 0 is 0. Bring your decimal point down. 9 and 6 is 15. Carry your 1. 1 plus 1 plus 2 is 4. 3.5 is actually can be written as 3.5000. Line your decimal up secondly. There's some borrowing going on, so notice what's happening. Eight from 10 is 2. 6 from 9 is 3. 0 from 9 is 9. 0 from 4 is 4. And 0 from 3 is 3. Remember to bring your decimal down. Likewise, line your decimals up. Once again, there is some borrowing going on, so notice what's happening. Eight from 10 is 2. 7 from 11 is 4. 3 from 10 is 7. 0 from 4 is 4. Bring your decimal down. 0 from 4 is 4. Multiplying decimals. When multiplying decimals, you can actually treat them like any other number. However, you do need to be mindful of how the decimals are presented. See the steps below and examples on the next slide. Step 1, multiply the decimals as if they were whole numbers. Step 2, remember to count the decimals after each number together. This will tell you where you placed or how many times to move the decimal back in your final answer. Multiply 34.8 times 0.62. So what we will do is turn 34.8 into 348 and turn 0.62 into 62, and we'll multiply. 8 times 2 is 16. Carry the 1. 2 times 4 plus 1 more is 9. 2 times 3 is 6. 6 times 8 is 48. Carry the 4. 6 times 4 plus 4 more gives you 28. Carry the 2. And 6 times 3 is 18 plus 2 more gives you 20. Add your numbers together. 34.8 had 1 decimal place and 0.62 had 2 decimal places, so 1 plus 2 equals 3 decimal places. In the final answer, the decimal will be moved back 3 places. So therefore, your answer is 21.576. Parenthesis 7.3, close parenthesis, times parenthesis negative 0.9, close parenthesis. 7.3 will be turned into 73, and 0.9 will be turned into 9. 9 times 3 is 20. Sarah carrying the 2. 9 times 7 plus 2 more gives you 65. Remember, it was a negative 9, so therefore the answer was going to be negative. 7.3 had 1 decimal place, and 0.9 had 1 decimal place. So 1 plus 1 equals 2 places. In the final answer, the decimal will be moved back 2 places. So therefore, the decimal belongs between the 6 and the 5, giving us a final answer of negative 6.57. Rounding decimals. Rounding decimals is actually quite simple. However, you must make sure you're rounding to the proper decimal place. So make sure to observe the decimal places carefully. See the steps below and examples on the next slide. Step 1. Find the digit to the right of the given decimal place value. Step 2. If that digit is 5 or greater, add 1 to the digit in the given decimal place value and drop all the remaining digits to its right. If this digit is less than 5, drop all the digits to the right of that given decimal place value. Round 482.7817 to the nearest hundredth. Well, the number 8 is in the hundreds place. The number to the right of it is the number 1. Remember, the rounding rule states that if the number to the right of the given decimal place value you are asked to round is 5 or greater, then add 1 to that number and drop the remaining digits. Since 1 is not 5 or greater, it will be dropped along with the remaining digits. Therefore, 482.7817 rounded to the nearest hundredth is 482.78. Round negative 0.03256 to the nearest thousandth. The number 2 is in the thousandths place. The number to the right of it is the number 5. However, remember, the rounding rule states that if the number to the right of the given decimal place value you are asked to round is 5 or greater, then add 1 to that number and drop the remaining digits. Since 5 is 5 or greater, add 1 to the 2, which makes it become 3, and drop the remaining digits. Therefore, negative 0.03256 rounded to the nearest thousandths is negative 0.033. Writing a fraction as a decimal. Writing a fraction as a decimal is very easily done. It really is just dividing the denominator into the numerator. Note, whenever the denominator is greater than the numerator, the resulting answer will be a decimal. See the examples on the next slide. Write 2/5 as a decimal. First thing you should observe is that the denominator 5 is greater than the numerator 2, so therefore the resulting answer will be a decimal. So therefore we'll take this back to old-fashioned division, and we'll take 5 and divide it into 2, or 2.0. Now 5 does not go into 2, so therefore that gets a 0, and 0 times 5 is 0, and 0 from 2 leaves 2. Bring your decimal up as well as bring your 0 down. 5 goes into 20 4 times even. 5 times 4 is 20. That gives us a remainder of 0. So therefore 2/5 as a decimal is 0.4. Write negative 3/8 as a decimal. First thing you should observe is that the denominator 8 is greater than the numerator 3. So therefore the resulting answer will be a decimal. So again, we'll go back to old-fashioned division. We'll take 8 divided into 3, or 3.0. 8 does not go into 3 evenly, so that gets a 0. We'll bring up our decimal point. 0 from 3 is 3. Bring down the 0. 8 goes into 30, a closest of 3 times, which is 24. 24 from 30 leaves 6. We will add a 0 for a placeholder, which means we'll bring down a 0. 8 goes into 60, 7 times, which is 56. 56 from 60 leaves 4. We'll add another 0 for a placeholder, which means we'll bring down one more 0. So now we have 8 goes into 40 5 times, and 8 times 5 is 40, leaving us a remainder of 0. Therefore, 3 over 8 as a decimal, or negative 3 over 8 as a decimal, is negative 0.375. Comparing decimals and fractions. Comparing decimals and fractions is pretty simple. Sometimes you'll be asked which is greater, lesser, or equal to when it comes to comparing. See the examples on the next slide. Insert a less than, greater than, or equal to when comparing 1 over 5 and 0.25. Well, 1 over 5 we know will be a decimal because the denominator is greater than the numerator. So we will do old-fashioned division and turn 1 over 5 into a decimal. So we'll take 5 divided into 1, or 1.0. We know that 5 does not go into 1, so that gets a 0. We will bring up our decimal point. 0 from 1 and leaves 1. We'll bring the 0 down, so now it becomes 10. 5 goes into 10, 2. And 5 times 2 is 10, which leaves a remainder of 0. So 1 over 5 is the same thing as saying 0.2 or 0.20. Now let's compare that with 0.25. Which number is bigger? Well, as you can see, they both have the same number in the tenths place, which is the 2. However, 0.20 has a 0 in its hundredths place, and 0.25 has a 5 in its hundredths place. Naturally, 5 is bigger than 0. Therefore, 0.25 is bigger than 0.20. So the proper symbol that makes this statement true is the less than. Remember, when it comes to inequality signs, the mouth will always open up to the biggest number and will always point to the smallest number.